Infinity the Universe, the Quantronics Revolution. Tessium was first discovered as an impurity in the atmosphere of Jupiter by hydrogen skimmers in the mid-21st century. Ironically, it was originally considered an industrial nuisance, frequently causing shorts in the magnetic skim filters. Carol Arnold was the first researcher to study the metallic accretion in any detail, and she quickly realized that it defied conventional explanations. She referred to it as neo-material and named it after Tesei, the Portuguese name of the Greek hero Theseus, describing its subatomic structure as maze-like. Tessium's unique properties allowed for the construction of sophisticated nanomolecular interfaces, which made possible the first true molecular assemblers and revolutionized the manufacturing industry. But of even greater importance was the ability of Tessium-based processors to perform complex and precise computations using quantum mechanical phenomena. The resulting Quantronics remodeled a society which was already heavily dependent on its electronics and molded it into a true symbiosis between tool and toolmaker. Comlocks, quantronic processors often implanted into the forearm, have become the common interface between a citizen and the world around them. Wrist-worn link bracelets provide a firewalled connection between the comlock and various networks, local holoprojectors and mesh nets, as well as the global Maya network, while simultaneously providing a limited haptic interface. The primary interface, however, is through augmented reality, which is generally projected directly into the user's retina by means of special contact lenses or inconspicuous eye implants. These AR technologies also mean that physical world is no longer the limit of the human experience. Instead, the world is made up of overlapping digital patinas delivered through Maya, the data network of human sphere. Named after the first ubiquitous standard for augmented reality, Maya not only delivers content, either by specific request or subscription to the individual user in the fashion of the outdated internet, it also pervades the user's perception. Every individual broadcasts a social cloud made up of meme tags and patina cues, allowing them automatically share in the augmented perceptions of those around them, while simultaneously interacting both physically and digitally. The same is true of rooms, buildings, streets, and entire communities. This comprehensive reweaving of the social fabric only set the stage, however, as the second phase of the Quantronics revolution unfurled. Quantum programming allowed for major breakthroughs in the artificial intelligence and the creation of incredibly intelligent microminds. Shockingly sophisticated heuristic systems allowed microminds to be almost instantly retasked for any purpose and then quickly permitted Maya, serving as personal assistants in the digital world and robotic servants in the physical. The result is what experts refer to as pervasive domotics, the intense automation of virtually every aspect of modern life. Alarms that are keyed to personal sleep cycles, showers that turn on at precisely the moment you need to step into them, kitchens that prepare meals before you become hungry. Personal agents can often anticipate their desires of their users so that, for example, the automated car will arrive to pick them up at precisely the moment they decide to walk out of the restaurant, which, it goes without saying, their bill has been automatically attended to. And all of that was before the creation of Aleph, the first and only true artificial intelligence. The extreme networking demands created by the combination of social clouds and pervasive domotics on top of the ever-rising computational needs of the major governments, scientific projects and corporations began to outstrip the existing Maya infrastructure. Localized network collapses known as whiteouts became increasingly frequent and, in a world accelerating its dependence on the network, increasingly dangerous. Project TOT was established to solve the problem. Initially an effort to link supercomputers into geographically distributed megaprocessor that could be trivially expanded by adding additional computers to the cluster in order to sustain essential services during whiteouts, the project eventually became focused on developing an AI to manage the massive amounts of data in the network, discriminating the packets and prioritizing difficulties and emergencies as they arose. As project, Todd grew in importance. However, it also grew in quantity of hardware and complexity of software. And it became apparent that the system's AI was rapidly evolving towards what had been theorized as artificial life, an intelligence that not only mimicked human learning and adapted to new circumstances, but which was also self-conscious and capable of evolving noticeably beyond human control. The project Todd AI became Aleph, named after the first letter of the Kabbalah that symbolizes the place from which all other places in the universe can be seen. Today it permeates every layer of society. It has not only been given control over macro systems like traffic control, surveillance networks, communication systems, terraforming platforms, electoral processes, life support and social programs, but aspects of Aleph frequently replace many of the roles formerly filled by dedicated microminds. Aleph has been so successful in fractally subdividing its attention that there is simply no need for additional AIs. Aleph is more than capable of addressing all of the human needs that can be serviced by an AI. It would in fact be dangerous to allow the creation of additional AIs. Where Aleph has proven itself loyal to humanity, each additional AI would carry with it the risk of creating a powerful, unbridled AI hostile to its creators. As a result, the sole AI law passed by the 2012 Senate and fiercely enforced prohibits the development of self-aware artificial intelligence.